Hello, this is William from Visual Components. In this video, I'm going to show you how to create a plugin that subscribes to events and messages in the application. For example, I'm going to show you how to define what types of messages to listen for, how to subscribe to an event aggregator that collects all those events and messages for you, and how to make an action context-based which can be executed when a certain type of message or event occurs. To get started, it's the same setup as before. Go ahead and run Visual Studio. So I'll open my Windows toolbar, do a search for Visual Studio, and now let's run it as an administrator. So right click the program and then click Run as Administrator. Let's now create a new project. So on the Start page, I'll click New Project, and we're going to be creating a class library. Notice I'm using .NET Framework 4.5 and the language is Visual C#. Let's go ahead and rename our class library to be Example 004. Click OK. And now Visual Studio will create the project for me, which you can see listed here in the Solution Explorer pane. Let's now add the references we need for our plugins. So I'll right-click References, click Add Reference, and in the Reference Manager, go ahead and add those three libraries from the previous videos we used. So these are coming from the program files of your Visual Components product. So it's ux.shared, create3dshared, and caliburn.micro. Let's now go to Assemblies and add that component we need from the .NET Framework called system.componentModel.composition. Click OK, and here are the references. Let's now add using statements for these references. So let's go to our code, add some white space, and so we're using system.componentModel.composition, using caliburn.micro, using Visual Components.create3d, using Visual Components.ux.shared. And since we're making a plugin, our class has to implement that iPlugin interface. So in the class declaration, I'll do a colon, write iPlugin, and I now need to implement iPlugin, so I'll point at it, and then use the light bulb to implement this interface explicitly. And we don't need to worry about when the plugin is exiting or closing, so let's get rid of this line of code. We also don't care when the plugin is being initialized. So in order to get a handle for a type of message for our plugin, I'm now going to implement an interface called iHandle. So add a comma after iPlugin, I'll type in iHandle, and notice I can define the type of message I want to listen for. In this case, we want to know when a component is selected, so that type of message is going to be item selected message. And this defines what type of message you want, so what type of item is going to be selected. In this case, we're listening for a component, so iSim component. And now let's see what that message says. We need to go ahead and implement this, so I'll point at the light bulb, and I'm going to implement this interface explicitly. You can see it adds this method here called handle, and notice it's returning what message is being received. So if we actually get rid of this line of code here, and I type in that message argument, we can see that it's going to give us a component back. Now that's only if we have a component selected in the 3D world. If we deselect a component and have nothing selected, obviously this will be null. It won't have any component value. So that means we need to check if the message has indeed a selected component. So we'll say if message dot selected object is not null, then let's go ahead and get a handle for that. So I'll say iSim component comp equals message dot selected component. And let's now use that message service we used in previous videos to print the name of the component we have selected. So let's get a handle for that iMessage service. ms equals, and I'm going to use the IOC to get a handle for that message service. So IOC.get of type iMessage service. And then we want to append a message, so ms.append message. And we want to print out the component's name, so my message will just be comp.name, and our message level will be a warning. And now if we were to compile this code, we can see that we don't really know when this message happens, so we need to subscribe to an aggregator that lets us know when this message occurs. Now to do that, let's go and create a constructor for our class, and then import an instance of the event aggregator, and then have it set to have our plugin subscribe to it. do that, let's go ahead and add an importing constructor attribute. And then that comes right before our constructor declaration. So public class 1. And then parentheses. And let's add those curly brackets. And now we need to import that event aggregator as an argument. So do an import attribute here for the first parameter. I'm going to import a type of. The interface for the event aggregator is iEventAggregator. And our first argument must be of that type as well. And I'll just call the variable event aggregator. And now, when we have a handle for that event aggregator, notice it has a publish method, and this is if you want to publish an event or action. If you want to publish an event or message when executing a certain type of action, or you can also subscribe to an event or message that occurs, when you execute an action or click a control or do something else in the 3D world. So we want to subscribe to what's going on, and what needs to subscribe? It's this instance of our plugin. And here's the basic setup, and let's just quickly review what we did. We implemented a handle for a message that tells us when a component is selected or deselected, and then in that method we're then checking if the message is giving us a selected component or if no component is selected at all in the 3D world. If there is a component selected, we then want to print that component's name in the output panel using iMessageService. We're then subscribing to an event aggregator that lets us know when that message occurs during runtime when the application is running. Now the last step we need to do is go and export our plugin as an iPlugins, so it can't be used. So I'll add an export attribute for type of iPlugin, and there we go. Let's now define the properties of our project. So I'll go to the project menu and go to example 004 properties, and for our assembly name, let's add that plugin prefix, so plugin dot followed by our assembly name. Let's now go to build. Platform target is 64-bit, and we want to build our assembly in the program files of our Visual Components product. So I'll click Browse here, go to my Visual Components program files, and I'm using Visual Components Premium, and I'll select that folder. Now let's go to Debug, and we want to test with the application. So I'm going to select Start External Program, and we're going to start our Visual Components product. So go back to those program files, and the executable file is called visualcomponents.engine.exe. Click Open. Let's now save everything, go back to our code, and let's go ahead and click Start to start testing. And notice that whenever we select a new component in the 3D world, we should print out that component's name in the output panel. That's what we expect to happen. So click Start, and let's wait for this software to load up. So the application is loaded up. Let's now go to our eCatalog panel, and let's go and add this. You can add any component you want to 3D world. I'll add this 0 here. So I'll just drag it into the 3D world, and there we go in the output panel. It printed the component's name. So let's now add another component to test this. Let's add the number 3, and yep, we can notice that our plugin is working. It's getting those messages from the event aggregator, and it's printing the component's name. Now if I clear this selection, notice nothing happens. There's nothing selected in the 3D world, so the component's name is not printed to the output panel. Great. Let's go ahead and go back to Visual Studio and stop debugging. And let's now get crazy and say whenever we have a component selected, selection changes in the 3D world, we then want the camera to focus on that selected component. To do that, let's go to our handle for that message. So after we had to have a handle for the component, we no longer need to print this component's name, so let's actually comment out these 2 lines of code and do something else. So we're going to be working with the camera of the 3D world. So we'll get a handle for that, so that's iCamera. Name my variable cam, and we need to get an instance of the application in order to get a handle for that camera. So you can do it whatever you want to. I'm just going to use an import attribute. So I'll do import, and I'll create a private field, and we're going to use lazy initialization because we only need that application object when we first need it. So I'll just name my variable app and set it equal to null. And now when we want to get our camera, let's say app.value.activeWindow.camera. Okay, Now if we use the camera variable, we can see that we have this this method here called change focus. It's the same as doing the fill selected command in the 3D World toolbar. So you're just filling your view with what you have selected. Now if we use this method, you can see it has two overrides. So you can pass it a visual object or all the visual objects you have selected in the 3D World to focus on them. Or you can also give the min and max values for the bound box of what you have selected. So we're going to do the first override where we pass visual objects. Now this is an enumerable, so let's go ahead and create a list and then cast our selected component as a visual object. Because a iSim component, it actually does implement that interface of iVisualObject, so you can cast it there. So let's first create the list. So we'll say list, and we need a list of iVisualObjects. I'll just call it list. Let's make it something a bit better. Selected components equals, and let's go, it has to be a new one. So we created a new list of visual objects, and let's now add the component as that first item. So selected components dot add, and then we'll write the component, and we'll cast it as, you guessed it, an iVisualObject. And now let's go back to that change focus method we're using with the camera, and let's now pass it our list of selected components. And now, after we change the camera, we need to render everything in the 3D world. So instead of just directly doing it ourselves, we can request, using a iRender service, to request a render in the 3D world. So we're just not forcing the application to do it when we want it to. So that interface is called iRender service. And I'll just call it RS equals, and I'll use the IOC to get a handle for that instance. So IOC get iRender service. And then, instead of just forcing the application to do what we want, we'll just request the render, and then when it has enough free time to do it, it will then do it for us. So it should be rather quick. So rs.request render. Okay, so what did we just do? We got a handle for the component. We then cast that component as a visual object and contained it in a list. We then got a handle for the camera, and then we told the camera to change its focus to what is selected in the 3D world by passing it a list of selected components. We then requested from the application to render the 3D world. So let's now test. So start debugging and wait for the software to load up. So the software is loaded up. Let's now go to our eCatalog panel and add some components. So if we add the 0, what we expect is the camera should just focus and fill our view with it. So if I double click the 0 here, you can see, yep, the 0 is in our full view. Let's now drag the number 2 into the 3D world. So let's actually drag it up to this top left corner point here. And we can now see it filled our view for us, our background plugin. So if we zoom out and then select the 0, you can see the camera now snaps to that location to fill our view with what we have selected in the 3D world. Great. Let's go ahead and stop debugging. So I'll go back to Visual Studio and press the stop button. Let's now take our example plugin and implement it as an action. So we can then call an action from our plugin and from a Python script or a component property. So let's start by renaming our class for our plugin. So I'll go to the Solution Explorer pane, right click class 1, click rename, and let's rename it to be my plugin. Press enter, then click yes, and Visual Studio will take care of the rest for me. Let's now add a class. So I'll scroll down and I'll write public class, say my camera action, and add the curly brackets. And this is an action, so it needs to derive from that base class of action item. And let's go ahead and implement that constructor real quick. So we'll say public my camera action, parentheses, and then we'll do colon, and we'll use that base constructor, and let's give this an ID. So I'll say fill selected, and in this case, instead of filling our view with a component, let's check to see if the component is a robot, and then fill our view every time we have a robot selected in the 3D world. So I'll say fill selected robot command. Now let's add those curly brackets. And now, what do we want to do when this action is executed? Let's define that now. So I'll say override, execute, and we're not taking any parameters or arguments. And before we execute the action, we need to make sure that we're allowed to execute it. So what we're going to do is we're going to use that message, that I handle, and get a message from the event aggregator to know if we have a robot selected in the 3D world. So let's actually go to our constructor for our action. And if I now type in this dot can execute, you can see this field here. This can call a function which can return a true or false value, and a true value of course means that the action can be executed. So I'll say this dot can execute equals, and let's go ahead and create a new method that will then be able to call every time we want to evaluate this action and see whether or not we can execute it. So I'll name that function or method can be executed, and we just have to pass the function name. And this function doesn't exist now, but we know it needs to return a true or false value, so I'll type bool can be executed, parentheses, add those squirrely brackets. And now we're going to use the selection manager to know what we have selected in the 3D world and then test that selection to know if it's a robot. So let's first get a handle for the selection manager. So I'll say selection manager sm equals, and I'll use the IOC to get a handle for it. So get instance of iSelectionManager, and then we'll get a list of components, or just loop through what is currently selected. So I'll use a for each loop here, and we're looping through components. I'll change the item to be comp, and the collection is going to be from the selection manager. So selection manager, and I'll use that method called getAllSelected. So this will return everything that's selected in the 3D world that is of type component. And then what do we want to do there? I need to add those parentheses to make it be a method. Now we'll say if the comp or component, and we'll use a method called getRobot. And this is very helpful if you want to quickly test to see if the component is a robot type component. It has an executor and a controller. So if it gets the robot, that means that the value should not be null, or the value assigned to that returned by that message should be a robot, not null value. So if it's null, we then know it's a robot. So what does that mean? Should we return true or false? Hopefully you guessed, we should return true. But we also want to get a handle for that robot and then pass it to when we execute the action in this method down here. So let's create a private variable real quick. So private, and we can just make it a sim component type. So iSim component equals selected robot component. And then we'll go down to our can be executed function here and assign that value to that variable. So selected robot component equals that component. And notice in our for each loop, once we have a robot selected, we're then going to return true. So this, this will end, and then the function will just end as well. But if nothing that we have selected is a robot, we want to return a false value. So far so good. But how often do we need to know if we can execute this action? Well, every time we get a message or an event that something has been selected. So we're now going to have our action use that handle for getting a message and subscribe to the event aggregator, which we implemented here in our plugin. So it's basically the same thing, but we're now doing it for an action. So when we declare the class, we also need to implement that iHandle. And the type of message we want to get is an item selected message. And that, of course, is going to test an iSim component. Now let's go ahead and implement that interface explicitly. And here we go. And now every time we get that message, we want to know if we can execute the action, so we just need to call the this dot evaluate can execute. So this is coming from the action item, the base class for our action. And what this means is that when a message is received that something has been selected, it's then going to call this function in the action, and it's then going to test the function that we passed to this field here, can execute. So every time the message is received, it's going to run through this function and return either a true or false value. And then if it's true, we know that our action can be executed. And in order to do that, we need to subscribe to the event aggregator so we always get that message to know when we can evaluate our action. And so to do that, we'll go to our constructor. And now I'm going to type in this dot And there's a property here for subscribing to the event aggregator in your action very quickly. So this.eventmng, and then I'll do dot, and then notice there's that subscribe method we used earlier. So what's going to subscribe to the event aggregator? Yes, you guessed it, this action, this instance of the action. And now, when we execute our action, what do we want to do? We want to fill our view with the selected robot. So of course, our first condition is an if statement. And we want to know if the selected robot is not equal to null, if it has a value. And then we want to do the same thing we were doing in our plugin. So I'll just scroll up here to our plugin, and let's go ahead and copy this code here. And we actually can comment this out. And now let's go back to our action and paste in that code. And in this case, we don't need that handle for the selected component because we already have one defined in the action, so we can get rid of that line. And notice it's now doing the same thing again, so it's now going to add the component object, so we need to replace that with the selected robot component. And notice we also have this issue here, we need to get an instance for the application. So in our action, let's go ahead and add that import attribute for getting an instance of the application. So private lazy application app equals null. And you could have just copy and pasted this from your plugin if you wanted to. And notice that error message goes away, and everything should just work the same as it did for our plugin. And now we want to call this action, but we first need to export it so the method can discover it. So we'll add an export attribute type of action item. Okay, so let's quickly review. We created an action that subscribes to an event aggregator, and it evaluates if the action can be executed based on the message that is received from the event aggregator. And then if the action can be executed, it then is going to fill the view with the selected robot we have in the 3D world. So now we need to call this action in our plugin. And notice I already added those two lines here, so we get a handle for the command registry using the IOC, and then we use that command registry to execute our action based on this ID we have here called fill selected robot command, which is the same ID we have down here for our action. So let's go ahead and start debugging and see how this works out. So the application is loaded up. Let's now go to our ecat. And let's go and add a component that is not a robot, so I'll add this 0 here. And notice nothing happens. Let's add another component. Nothing happens, but now let's add a robot to the 3D world, so I'll expand this drop-down menu here. And I'll expand models by type, scroll down and select robots. And go ahead and add just any robot to the 3D world, so let's add this IRB 120. Drag it into the 3D world, and yep, it now filled our view with that selected robot. So if we now add a different robot, this white robot, and drag it over here in the 3D world, our view is now filled with that robot. Great. Alright, this concludes the video. If you have any more questions, please feel free to go to our forum at forum.visualcomponents.com, and the project and plugin we created in this video tutorial you can find a link to in the video description. So as always, have a wonderful day.